using like denominators with fraction division. So let's look at like denominators or how they can make fraction division actually easier. Our ICANs are, I can use understanding of least common multiples to find like denominators as a fraction division strategy. So make sure you have your ICANs, today's date, page number back in your table of contents, and you're ready to move on. Quotients, let's take a look. So let's see if we can do these in our heads. If you think about it, 8 divided by 2, I hope we all know, is 4. If we think of it as 8 ones divided by 2 ones, still 4. 8 tens divided by 2 tens, well, 8 tens would be 80, right? And 2 tens would be 20. 80 divided by 20 is still 4. 8 thousands divided by 2 thousands, again, gonna be 4. 8 tenths divided by 2 tenths, 4. 8 thirds divided by 2 thirds, 4. Why is this true? Well, think about it. In every one of these, we have what we had in the very beginning, 8 divided by 2, right? And since the words that are with them are the same, it comes out the same every time. So when I have, like for this example here, I have 8 thirds divided by 2 thirds, it doesn't even matter that the denominator is what it is. If it's exactly the same, all I really care about is this part up here, as the 8 divided by 2. That's why 80 divided by 20 still is 4. That's why 8,000 divided by 2,000 is still 4. We're not worried about those except to make sure that they are the same. If they're the same, then we only really care about these digits right here. So let's look a little further in this whole same denominator stuff. So if I have 8 ninths divided by 2 ninths, we can think about this as 8 groups of ninths, and then how many groups of 2 ninths that we get out of this. Well, this entire tape diagram would be one whole. 8 ninths would be 8 of those. And then if we're looking at taking those and making them into groups of 2 ninths, well, we made the ninths. We already had ninths. This was 8 ninths. If this had been the whole number 8 divided by 2 ninths, we would have taken that 8 and split it up into all of those into ninths and then find out how many groups of 2 were in there. But that's not what it's saying here. What it's saying is I've got 8 ninths, and I want to find out how many groups of 2 ninths what I can get. Well, if I've already got them in ninths, do I even care that they're ninths? No, because really it's the same thing as doing 8 divided by 2. So since I have the same denominators, I can go through and actually just use the numerators to solve. So if I have something like 9/12 divided by 1/4, those don't have the same denominators, but can I make them into the same denominators? Probably can. What would be the least common multiple for 4 and 12? Yeah, 12 would be it because 4 is a factor of 12, so we can leave that alone. So we can rewrite this as 9/12 divided by And then I've got to rewrite that as twelfths. Multiply both those by 3 to make our new one 3/12. So now I'm really thinking about just forget the denominator part since those are the same now. 9 divided by 3, which gets me 3. So as long as I can make my denominators the same, then I can just worry about dividing the numerators. Try this one out. So what you should have done is you should have taken that 7/9, and 9 is a multiple of 3, so I can leave the 7/9 alone. I have to multiply both of those by 3 to get my answer. So again, I don't even care about the ninths because they're going to wipe out because they're not going to matter. So then I have just the 7 divided by the 3, right? Or 7/3. 3 can go into that 7 2 times. That leaves me with 1 left. So it's either 7/3 or 2 1/3. Go ahead and try each of these. So 3/4 divided by 1/4. They already have like denominators, right? So really it's just 3 divided by 1. That gets me 3. 4/5 divided by 2/5. Again, I already have like denominators. So I'm really thinking about 4 divided by 2, which is 2. Next one I got here is 7/8 divided by 1/4. But those aren't like denominators. However, that 4 is a factor of 8, so I can go ahead and make that into eighths, which gives me 2/8. Remember that when you convert one part of a fraction, you've got to convert the other part. So then those eighths we don't need to worry about again. It's just 7 divided by 2 at this point. And that gives you 3 1/2. 13/10 divided by 1/5, same thing. We end up with 13/10 still because 5 is a factor of 10. That would give us 2/10. Same as 13 divided by 2, again, because the tenths would end up disappearing. 2 goes into that 13 6 times, and you got 1 left over to make 1/2. Last one, same thing. They're not the same denominator. This is 18, this is 9. 9's a factor of 18. So I'm going to make that into 22/18. And I'm going to divide that by 6/18. That gives me 22/6. 6 will go in there. What? 3 times. That leaves me with 4/6, or 3 2/3. Some of you might have noticed that I actually could, since 9 is a factor of 18 and both of these are even, I actually could divide both of those by 2. So instead, I could have done like this, kept my 11/9, and divide that instead, dividing both those by 2, I get 3/9. Does it matter that I changed this and looked at factors and went smaller? No, because the major thing with this entire thing is that I get the same denominator. So then I still have my 11, still have my 3, and guess what? 3 will go into 11 3 times with 2 left over out of the 3. So it still gets the same answer here and here. It's just we end up reducing. It really doesn't matter as long as we've made those like denominators. And if we make those like denominators, remember that we have to adjust one or both of those so that way they come out to what their equivalent fraction is. We can't just change the numbers without making sure that we've used the same factor on the numerator and denominator. So, what do we find out? If numerators are the same, you can just flat out ignore them and divide the numerators. Why is that true? Well, think back. When we talked about something like this, where we had the 8/9 divided by 2/9, it's already 8/9. All we're doing is making groups of 2/9. Well, if they're already in ninths, all we're doing is making groups of 2 out of the 8. So that's why that works. If the denominators aren't the same, we can find the least common multiple, make equivalent fractions, and then divide just the numerators. Why is this true? It's the exact same reason that the previous one was true. If we've already got them into the cut up in the same types of groups, then all we're doing is just putting them together to make them work out. I can even think of something like, let's say we did 3/4 divided by, let's go with something like 1/5. Not the same denominators right now, but can we make them? Sure. What's the least common multiple for both of those? 20. So now we've got 20ths for our denominators. That was times 5 to make that, so I'd take that times 5. That makes 15. 4 times 5 gives me 20, so 4 times 1 is 4. So then we just have 15 divided by 4, right? 4 will go into that 15 3 times. That gives us 12. 15 minus 12 gives us 3. 3 3/4. So the big thing here is that whenever we have fractions in division, we can make like denominators and just do the division piece with the numerators. We could still do similar to what we did before when we had multiplying by the denominator and then dividing by the numerator. But this is just another strategy that you can use that in some ways can make it a lot simpler. All right. Thanks for watching. Make sure you've got all of your notes down before you move on.